Hey folks, how we doing? We're looking at practice 1 for statistics. All right, this is an actual test that was given, and so my hope is that you're going to be a little more comfortable with the kinds of problems that you're going to see on the test, and that you'll be able to recognize all of them and be able to do at least parts of all of them what you see. So anyway, number 1, it says we've got 12 values of x that are shown here, and they want us to find the mean and the standard deviation. The thing is, they throw in this little thing with its being x minus 1,760. Well, basically what that means is that we're going to take away 1,760 from every one of these x's. So that's not that big of a deal. We can do that. All we got to do is subtract, and some of them are going to be really easy to do. I mean, for example, this first one, if I take away that, that's obviously going to be 1.6. Well, I'm going to do this for all those numbers, and I'm going to get these. Now, when I've got my numbers, my x's, after I've taken away, I'm going to add them all up, and then I'm going to divide by the number of numbers. You obviously could also use your calculator, and I'd recommend that you do that, but I would be writing the formula down just in case you push the wrong button, so you show that you're using the right method. Anyway, when we do it in this case, we're going to find out that the mean is 1.23. Now, again, if I put these numbers in the calculator, I should be able to find the standard deviation, but you should also know how to do it by hand, and the way we can find the standard deviation is by taking the squares of all these numbers, adding them up and dividing by n, and then subtracting the mean squared. And again, if you do that, you should find out that the standard deviation is 1.39, and hopefully that's going to match what you get when you use your calculator. Okay, so now that we know this mean, what we got to make sure we are clear about is they asked us to hence find the mean and the standard deviation of x. Now, it doesn't make a difference if we use these values or these values. The standard deviation is going to be the same, especially if you use a calculator. But the thing is, the mean is going to be different. Obviously, the mean of these numbers is not the mean of these numbers up here. And so what I've got to do is I've got to take the mean that I found, 1.23, and then I've got to add back the number I took away from each one of the values, which gives me a mean of 1,761.23. Now in number 2, we've got a bag that's contained, or we got 10 balloons in a bag, 9 yellow balloons, 12 green balloons, and 9 white balloons. Kind of think of these like the marble problems in a bag. All right, so we're going to take 7 balloons out at random without replacement, and they need to find the probability that exactly 3 of them are green. Well, keep in mind that when we're talking about this kind of thing, well, we got to consider all our pieces, and I kind of pull the information out of the paragraph, makes it a little bit easier, and you can get rid of the words and use just letters. All right, so you notice how they use the word selected. That is the same as being chosen. And probability is just basically the number of ways that we're interested in divided by the number of ways that it could possibly happen. So if we could figure out the number of ways to find out how to choose these balloons, and then divide it by the total number of ways to choose 7 balloons out of all these, we could have the probability. So let's start with that. Probability. All right, so let's see. We've got 40 balloons, and we're choosing 7. So if I do 40 choose 7, that's going to give me the total number of ways that I could just pick 7 balloons out of 40. And then I need the tops. Well, if I'm going to do the tops, I need to consider how many greens I want. Well, I've got 12, and I want to choose 3 greens. So that's a good way to get me the number of ways to choose the 3 out of the 12 greens. And then the thing is, I've got the other balloons. Now, keep in mind, there are 40 balloons altogether, and I've just talked about what I'm going to do with the 12 greens. I only want to get 3 of them. So there are 28 balloons left. So now what I need to do is figure out how I'm going to pick 4 out of the other 28. Well, again, I can choose 4 out of 28. and then just multiply those together and divide by this 40 choose 7. When you do that, you should get this, and then just divide. And at the end, you should find out that it's 0.242 or 24.2%. Now, keep in mind what we did here. We found out the number of ways to choose the 3 greens, and then we multiplied it by the ways to find the other 4 out of all the other 28. That's how we got our 7, and then we divided it by 40 choose 7. All right, so in problem number 3, they tell us that it's found that 10% of the population enjoy watching historical drama on television. This is basically another way of telling you that the probability that someone enjoys watching historical drama is 10%. Now you also notice that they say that we're using an appropriate approximation. Well, when I see that, I'm thinking that this is a binomial distribution and that they want to approximate it by using a normal distribution. So whenever you see those words, it's kind of a good clue. And you'll notice that they've got 160 people chosen randomly. That's a number of trials. So let's write this binomial distribution. We've got 160 trials, and we need probability of a success, which is going to be 10%. So that's our guy. Now keep in mind, this only works, I only can use this approximation if when I multiply 0.10 or n times the mean, that it's going to be greater than 5, and then 0.9 times the mean is going to be greater than 5. And it is. So I got n times p. That's going to give me my mean. So when I rewrite this as a normal distribution, I have n times p, or that's going to give me 16. Now I need a variance, and all I got to do now is do n times p times q, which is the mean times q, which is going to be 14.4. We can treat this problem just like a normal distribution. And I start to go write it, but then you got to remember, when you're doing an approximation, we've got to use a continuity correction, which means we're going to put 0.5 below this value that we're talking about, 16, or above. So we've got to take a look at what we're talking about. In this case, we're saying that we're looking at x being greater than 17. Well, if we don't want it to include the 17, then the number that we're going to use isn't going to be 16.5 because that's going to include the 17. So what we're going to do is when we do try our z-score, we're going to use 17.5 minus the mean, and then divide that by the standard deviation, which in this case is going to be the square root of 14.4. And then all we got to do is figure out what this z-score ends up being. And we take a quick look when we do the normal distribution, and what I see here is that I know that the number 17 is bigger than the mean. So that means that this z-score is going to be over here on the right-hand side, and it's going to be greater than. Well, remember, the table doesn't work that way. I have to go the other direction. I have to go to the left. So I'm going to find this less than, which is what my table does. And by the way, when I did this 17.5 minus 16 divided by the square root of 14.4, I got 0.3953. Now the thing is, like I said, what I'm going to do is, that's a z-score, but my tables only go to the left. And that's going to give me the probability that's everything to the left, which I'm fine with, even though I need the probability of what's on the right. Because when I find this probability on the left, all I'm going to do is take it away from 1, and that'll be the probability that I need. So when you go to the table, you're going to find out that this probability is 0.6536, but then I have to take that away from 1, and I find that the probability that I'm talking about is going to be 0.3464, or if I round to 3 significant figures, 0.346. Okay? So now let's take a look at number 4. In number 4, they say the weights in kilograms of packets of cereal are listed over here. Obviously, we've got a stem and leaf plot, and they want us to draw a box and whiskers plot to represent the data. And so it's important that we keep in mind all the things we need when we're doing a box and whisker plot. And we basically need the low point, we need the first quartile, we need the median, the third quartile, and the highest point. And a couple of these pieces are really easy to find. In order to do the median, well, I just got to find out the total number of pieces of data and then multiply that times 0.5 and then round it and I'm going to find out that the median is going to be the 30th piece of data. And see, since this is already ranked, it's in order on my stem and leaf plot, it's pretty easy for me to figure out where that guy is. Here I've got 19, so I just count all the way over, and I find out that this guy right here is this 30th piece of data. That's the median. And so I just fill that in. I got 0.705 or 7. And now I'm going to look for the first quartile. Keep in mind what that means is it's the median of the bottom half, in this case the bottom 29. So again, I take 29 times 0.5 and I find out that that's going to be 14.5. I'm looking for the 15th piece of data, which again, because these numbers on the side, it's pretty easy to do. I've got 7. Now I got to do is keep on counting, and I find out that that piece right there is our 15th piece of data, and so that's the first quartile right there. And so now all I got to do is find the third quartile, which, keep in mind, that's the median of the upper 29, the upper half. And so I already know it's going to be 15 away from there. If I start at the median and start counting 15, I can find out that this right here is the third quartile number. And so then all I got to do is jot that down. And then the lower number, that's easy. And then the higher number, that's easy also. So now all I got to do is figure out what I'm going to do with my graph here. And you'll notice that they've got this laid out. And this goes, I can go by tens here. And I'm going to use the 747. I'm going to use all the stems as my, down here is my x values, or, the x-axis. And see, now all I've got to do is plot my points. And you don't have to list them next to them, but it's not necessarily a bad idea because it makes it really clear that you know what the points are in case you miscounted or whatever. But anyway, I list all the points, I draw my box, and then I go ahead and connect the two things. One of the big deals is you got to make sure that you define your scale. In this case, we're weight in kilograms. And you can write this stuff on the top if you want, but you really don't have to. What's important is that you have a uniform scale along the bottom and that the lines don't go through the box. That's something that's listed on the marking scheme that they obviously look for. All right, now the next one. What we're talking about is name the distribution that this could be. Well, you'll notice that it's symmetrical, and I can tell that by looking at the stem and leaf plot, and I also can tell that by looking at the box and whisker plot. And a distribution that's symmetrical, and most of the data is in the middle, the tail's off on the ends very quickly, is a good sign that we're looking at, it could be approximated by normal distribution. All right, so a situation where we've got to figure out the number of ways we can choose. Now we want Alex, or whatever his name is, Alex, to get an odd number. Well, basically, if he gets an odd number, then the other guy gets an odd number. So what I'm going to do is figure out how many ways can he get 1. Well, let's choose 12, 1. And then if I want to figure out how many ways he could get 3, that's 12, choose 3. And how many ways could he choose 5 out of the 12? That's 12, choose 5. And then how many ways can he get 7? That's 12, choose 7. And then 12, choose 9. And then choose 11. All I've got to do now is add up all these ways, and I get the total number of ways that could happen. Now, in this next one, I've got another plate of cakes. Cupcakes, and they have different colors, and then there's brownies. And in this one they talk about the names are being arranged so the brownies aren't next to each other. Well, this is a stars and bars problem. Basically all we've got to do is name the stars and the bars. The bars are the ones we have the most of, in this case cakes, and so we put them here, and then we can figure out where the brownies could go. And that's where the stars go. Now the thing is, I've got more spots for brownies than I actually have brownies, but I still can figure this out pretty easily. All I got to do now is figure out the ways that the bars can be arranged, And so that's there's 7 of them, so that's 7 factorial. And then I got to figure out the ways I can put brownies into the 8 spots. Well, there's only 4 brownies, so that means I could rearrange them 8 permutation 4. And when I multiply those together, that's going to give me the total number of ways that these guys can be arranged without having brownies being next to each other. So in the next one, we got more food, only in this case you'll notice how they go out of their way to talk about how they're identical. Okay, 6 identical shortbread, 6 identical chocolate biscuits, and identical gingerbread biscuits. Okay, so they're placing them in a row, and how many different arrangements are possible? Well, let's revisit something that we've done with arranging things, and a lot of times we do it with the words. So think about the ways we can arrange these words. All right, if I arrange the word war, that's words 4 factorial, and then ball. Well, that's going to be 4 factorial divided by 2 factorial because the 2 L's are identical. Remember when we do that? And then the next one, if I've got cakes, but in this case, what I want to do is keep the vowels together. Well, basically, I'm going to take the vowels and move them to one side, and I'm going to consider them one thing. So now I've got 4 factorial times 2 factorial because the 4 things, vowels and then C, K, and S, that's my 4 factorial. But then I've got to multiply it by the different ways the vowels can be arranged. In this case, there's only 2 of them, so it's 2 factorial. If there had been 3 of them, there'd be 3 factorial. So now, let's think about if it was ball and to keep the L's together. Well, in this case, what we're talking about is 3 factorial. There's 3 things. But now when I take a look at the L's, well, that's 2 factorial. But when I divide by the fact that there's 2 of them identical, 2 factorial divided by 2 factorial is the same thing. I mean, if they're identical, there's only one way for them to go because they're identical. So I don't really have to do that part. Anyway, let's go look at our problem now. I've got these chocolate biscuits, and then I got the shortbread, and I got the gingerbread. But these chocolate ones are going to stay together. So remember, they're identical. So when I look at this, I've got nine things. The chocolate, and then all the rest of them. And then I do 9 factorial. Now, out of my things, my 9 things, the shortbread, they're identical, and there's 6 of them. And the gingerbread, they're identical, there are 2 of them. So I've got to do this. But then I've got to multiply by the 4 factorial divided by 4 factorial to get 252. Now, this problem here, we've got cards and 2 different decks. And then we're pulling 2 cards, one from each deck, and then we're adding them together. And I want you to think about the dice problem where you've got 2 dice, and we have to, throw the dice and then figure out the sum of the 2 dice. And how we figure out the different ways that could happen. Well, it's very similar to that. Remember we went 1, 2, 3, 4, 5, 6, and then we added them and we put them into a table? We're going to do the same thing with this, only with these cards. And initially it looks like it's going to be a real pain because there's so many of them, but the numbers have been chosen on purpose to make it so it's not that difficult. All right, and when you add these together, you'll see that they start developing patterns, and you can kind of anticipate where they're going to go. But anyway, it's pretty easy to fill out. Once I've done that, I know that I've got 6 times 10 are 60 possibilities. And so if I take a look, I've got 8 out of 60, or 2 over 15, 2s. And remember, x is equal to 2. That's what I'm looking about. So the number of times 2 comes up when I draw 2 cards. When I add them together, there are 8 of them. 8 out of 60. So that reduces to 2 out of 15. You also could use probabilities when you're doing this. You could find the probability of getting a 0 and then a 2. They can only happen one way. So it's 2/10 times 4/6, and that also gives you 8 over 60, or 2/15. Now, if I want to do a probability distribution, I've got to list all the probable numbers. In this case, it's 0, 1, 2, 3, and 5. And then I got to put the probabilities of each one. Well, they're pretty easy to find because I got this table right there listing all the different ways it could possibly happen. And you can see where these numbers are coming from. All right, all you got to do is count them and divide them by 60. And remember, they all should add up to 1, and that's like a good way to check. All right, so now it says, given that x is equal to 3, find the probability that the card chosen from pack A is a 1. Well, remember when we're doing a given probability, it's really the probability of both happening divided by the probability of the given thing happening. So in this case, the probability that A is equal to 1 given that x is equal to 3. So what's the probability of A being 1 and x equal 3? Well, you can take a look at our table and you can see how that's happened. How many times did it happen? Well, it happened 20 out of 60 times. Now, how many times could a 3 come up? Well, 26 out of 60 times. So when I divide these, I get 20 out of 26, or 10/13. Now, in this next one, you'll notice how they're asking for the mean and the standard deviation. This is screaming of a simultaneously. So there are two different ways to make equations, and then two things we're looking for. So when we go to make our first equation, we're less than 7.7, and they give us the probability. And I do a quick look, and I realize that 17% is not very much. That's going to put us below the mean. That means my z-value is going to be negative. And I know that there's no negative z-values on my table, but it's got a symmetrical brother on this side who's positive, and all I got to do is figure out what the z-value is. So if I do the probability of 1 minus 0.175 and look at the table in the middle and find that probability, that'll give me the z-score that's positive. And then all I've got to do is match up the z-score and the z-score. This is the way I find the z-score. And then I go back here, and remember, I'm not using 0.175, I'm using 0.825. And that's everything on this side. Now, that's going to give me the positive z, but remember, the one I want is on the other side, so I make it negative. And then all I got to do is multiply this, and I got myself a nice equation. Well, now I'm going to do the same thing with the other thing. X is greater than 8.8, and it's equal to 0.25. Well, now that's on the positive side of the mean. But however, my scale doesn't go that way. It goes to the left. Well, that's 75%. I can find that. And so that z-score is going to be 0.674. I've got two equations now. All I'm going to do is multiply the second one times -1, and then add them together. The mu's will cancel out, leaving me with just the thetas, or the standard deviations, to figure out. And all I got to do is divide. And once I have the standard deviation, all I've got to do is plug it back in. Remember, don't round. I mean, take the whole standard deviation number and plug that back into one of the original equations so you can find the mean. And then you can put your answers in standard, significant figures, 3 significant figures. Now, in this next part, they're saying find the probability that we've got these standard deviation, and they give it to us. And it's a normal distribution. But you'll notice they talk about find the probability of 3 out of 5 women. Well, we've got trials. So let's write this. First, probability that L is less than 8.2. And we can figure that out. That's a probability. But if I've got these trials, and it's a binomial distribution, and so what I need is a probability of success. And so that's what they want me to do with this normal distribution, is figure out the probability of success. And so it's above the mean. So that's actually going to be pretty easy because it's actually going to work the way my table works, everything to the left. So when I go and subtract 8.2 minus 7.9 and divide it by 0.44, I get a z-score of 0.6818, and now I do is match it up to a probability, and I get that. Now, that's a probability of it being short. And so now, that's a probability of success. And the number of trials is, let's see, number of trials is actually 5. And so they want to know how many out of the 5 trials is going to be 3. So I just got to do 5 choose 3, and then the probability of success to the third power, and then the probability of failure to the second power, and that's going to give me the total probability. All right, the next one. I've got a random variable x that's got a normal distribution with a mean and a standard deviation. And they don't give me what those are, but they do tell me that the mean is equal to the standard deviation. And so what I can do is I can try finding the z-score, only try to replace everything with the, try to make it the same variable. And so when I do this, you can see I got 1.5 mu minus 1 mu, which is going to be 0.5 mu. And then when I divide 0.5 mu divided by mu, I get 0.5. And see, now I've got a z-score. So all I got to do is find the probability that matches up with that. And if I go to look at the table, I should find out that it is 0.6915. It's